Hey everyone, let's take a look at Achieve section 3.4, number 9. In this one, we're going to be using the following formula that's in section 3.4 of the textbook. This is the formula for the height of an object, a projectile that's undergoing free fall motion. The only influence it has is gravity at standard sea level on the planet Earth, that is. It would neglect wind resistance and all that. This is the formula. There's a lot of variables here and strange things with subscripts. So the S is the actual height. This gives the height of the projectile or object, and it could be in feet or meters depending on the units you use for G, which I'll explain here in a minute. The T is the time in seconds. The V sub 0, that's the initial velocity that the object has when you start at time 0. And velocity, if you're throwing the object upward, would be positive. If you're throwing it downward, it would be negative. If it's just dropped from rest, for instance, then the velocity initially would be 0. S sub 0 is the initial height of the object above ground level. So ground level, S is 0. If you're, say, 100 feet above ground initially, then your S sub 0 would be 100 feet. Again, the measurements could be in feet or meters. And that depends on G. G is the acceleration due to gravity. It's either 32 feet per second squared or 9.8 meters per second squared. A lot of times, if I'm giving a test, I'll just go ahead and plug in the appropriate value of G so you won't have to worry about it. So if I'm using feet per second squared here, if I'm using the English system of units, then -1/2 times 32, this would just be -16 t squared right here. If we're using the metric system here, meters per second squared, 9.8, this would be 1/2 of 9.8, -4.9 t squared. Okay, so I would probably give that to you like on a test. But if there's ever any questions about which one to use, if you're not sure, I would certainly clarify that for you. One thing is certainly in this particular problem, let's read it. We have a projectile that's launched into the air from the ground level with an initial velocity 64 meters per second, and so it's positive, so that means we're launching it straight up at that initial velocity. What's the maximum height the projectile reaches, right? We shoot it up, the projectile goes up, and then it will reach a maximum height and come back down. So we're going to round that maximum height to 2 decimal places. Make sure you read carefully, the directions there. And then we are going to use G equals 9.8 meters per second squared. So that tells you everything will be in, obviously we're in meters for the distance or length units, for the height units, and the time is in seconds. Okay, so with that, again, plugging into our equation here, -1/2 G is 9.8 t squared, and the initial velocity V sub 0, right, is 64, so that's 64 t. And what's the initial height? Well, since we're launched from the ground level, initial height is 0, that's ground level. So if I plug that in, I get this. This gives me my position or height above ground at any time in seconds. So if I plug in t equals 0, of course, I get 0 because that's initially where we're at on ground level. If I plug in t equal 1, I get -4.9 plus 64. That's the number of meters that I am above ground after 1 second. Okay. What we're interested in, what's the maximum height? And you could plug in different values of t and just see the behavior of this function and sort of see how it goes up, and then eventually we'll come back down. But we're going to find it using calculus. And the way we find the maximum height with calculus is to find when the object's velocity is 0, right? When it's changing from a positive velocity going up, negative velocity coming down, right? So at that point, the velocity is 0 at the maximum height. So we need to find the velocity first. Remember, the velocity is the rate of change of the position or height of the object with respect to time. So I just take the derivative of this with respect to time. By the power rule, right, bring the 2 down, this becomes -9.8 t. Derivative 64 t is 64. A real easy derivative to find. So when is this velocity 0? Because that's when we're going to have our maximum height. Well, I just set that equal to 0, and I solve for t. So if this is true, I must have 9.8 t equal to 64. And if I divide both sides by 9.8, I get about 6.53. Now this is the t again. This is the time to reach the maximum height. What is the actual maximum height? Well, I need to plug that back into our function that gives us the height at any time t. So I let t be this value and plug it in. Now be careful about rounding here. So I've rounded this time to 6.53 here. In my calculator, if I'm doing this problem, what I'm going to do is I'm going to take that time, 6.4 divided by 9.8. And you can see what I get there. I rounded off to about 0.653. But so you don't have any round off error. Notice how I put it in here as the exact value. So I would just use the answer key in the calculator. In other words, this is stored into the answer. So I'm going to do negative 4.9 times answer squared. Remember, the answer is this little, the blue right above the little negative sign. So I hit second answer, right, squared. So square that, plus 64 times answer. Okay. And that's going to give me my height. Oops, I messed up something. What did I do wrong? Negative 4.9 answer square. Oh, I did 6.4 instead of 64. My goodness, that's bad. I'm off by a factor of 10. So let me change that real quick. I'm sorry. Let me just clear that out. So 64, sorry about the confusion there, divided by 9.8. I even said I got 6.53 and I didn't in the calculator. So this makes better sense. There's 6.53. And hey, if you make this mistake, that I just did, that's fine. Check your answer if you can. But I'm going to use the entry command in the calculator. If I hit second entry, it recopies the last thing I did. If I hit second entry again, it gets me back to this, which is what I wanted to have with this as my answer. And so now I can get the correct value. Okay, sorry about that. So round it off. So here's what's important though. Make sure you realize, since we're rounding to 2 decimal places, 208.98, not 97, because that 9 after the 7, of course, rounds the 7 up to 8. So, okay. Hope that makes sense. And if you have questions, as always, please let me know.